I mean, we will probably make a slide. So we're all jokes here as we start the Fusion 360 class officially because it is 7 p.m. Hey, will somebody turn off half of the lights for me? Does somebody have that app loaded on their phone? Um, just half of them, so we can everybody else can still see. Okay, cool. I will. Yeah, apparently we've made a lot of cup holders in this class. So we spent this time like I know there's cup holders around here somewhere. This is evidence that we've been doing this class for a long time. We've got cup holders that go back to 2018 here. Um, in fact, I know what this cup holder from 2018 was for. This was for a project at the museum where we had our robot pour cocktails at our gala. So I designed this whole table that the robot picked up drinks from, and then like poured them, and we had cup holders. So people put their drink in a cup holder, and it's hit a little button with a little micro switch. Anyway, it's a whole thing. It's probably on the internet somewhere. But so yeah, we've made a lot of cup holders in this class. Um, let's just go ahead and hide my cup holder problem from everybody. Because now we're going to talk about my joint problem. And by that I mean we're going to assemble some joints. So this class is going to be a little bit more theory than we're used to, because we're going to create some joints, and I'll show you how to automate them and how to move them around and how to drive them and stuff like that. So we don't have like a specific project that we're going to do other than we're going to model a bunch of components that we can make move. And hopefully you'll be able to take the knowledge of joints out into the world and your own projects. So let's go ahead and start by creating a sketch. So I'm going to go ahead and click on create. I'm going to choose to create a sketch, and I'm going to draw that sketch on my front plane. It doesn't really matter. Again, this is a theory class, so we need to pick a plane. So I'm going to draw on my front plane. On that plane, I am going to start by drawing a line. Now, I'm going to draw a line from my origin, and this is going to be, we're going to make a couple of, I don't know, leg segments, I guess you could say. Let's make it 5 inches. 5 inches will be plenty. And then at the ends of each end point on that line, I'm going to make a center diameter circle. I'm actually going to make 2 center diameter circles. So the first center diameter circle is going to be 1/4 of an inch. And I'm going to zoom in here, and I'm going to move out my measurement so we can see it a little bit more. The second center diameter circle is going to be 1 full inch. And we're going to do that same series of 2 circles at the other end of our um, line. So circle, center diameter circle. We're making one of them 1/4 of an inch. We're making another one. Center diameter circle. And we're making it a 1 inch. All right. Cool. Cool. Moving along. The last thing that we want to do here is we would like to connect our 2 circles with some lines that are tangent to each one of those circles. So the way that I like to do that is I like to save myself some clicks. So you could just click and place your line on that circle, and then when I get over to the other circle, I can see that little tangent constraint popping up. However, I've only got the tangent C on one side of this circle. It's not really tangent over here, it's just kind of close to tangent. So I can add a tangent constraint after the fact, or I could save myself the need to add that tangent constraint after the fact. If I, here's pro tip number 1. Pro tip number 1 is if I hold down the shift key before I click on to start my line, so if I am holding down the shift key and I click to place my line, now you can see holding down the shift key is kind of forcing that tangency on that first circle already. And I'm still holding down my shift key here, and now I can move my line over to my other circle, and you can see my other tangency constraint is kind of popping up there. And still holding down the shift key. Now I click, and now I've placed a line that's tangent to both of those circles automagically.
You gonna do keyboard shortcuts next week?
Yeah, just nothing but keyboard shortcuts. I mean, you can make your own keyboard shortcuts. Are we aware of that? So let's say you find yourself using the 3-point rectangle tool a lot. 3-point rectangle tool does not have a keyboard shortcut.
No.
Rectangle tool is R. But as you hover over these options, those little 3 dots right there, if you click on the little 3 dots that appear, you can say, hey, change keyboard shortcut. And when you change that keyboard shortcut, if it doesn't have one, you're giving it one. So the keyboard shortcut here, I'm going to make Shift Control R. Shift Control R. Just mash down the entire left-hand side of your keyboard and push the R key. And that is now my 3-point rectangle. Keyboard shortcut.
Beautiful center rectangles.
There you go. Some people love their center rectangles. You can make a keyboard shortcut for it now.
Shift C.
There we go. All right, perfect. So now let us let's make just a pattern of this. Can we make a pattern of it? Yeah, it's fine. All right, so we'll come down to create, and I'm gonna choose to make a circular pattern. And that's the pattern that I'm going to make is of, no, not the center line. 2 of my circles on one side of my line. I'm kind of choosing the circles on the side that is not my origin. Because what I'm going to do here is I'm going to rotate this down. I'm going to make a pattern of one of these at a 90-degree angle. So I've got two arms that we can make a joint out of. And I'm intentionally making my joint in the origin because it'll be really easy for me to remember where my joint is. And there's some extra axes that come with the origin that can be handy for a joint. The extra axes that kind of are already there, our X, our Y, and our Z axis are kind of living at this place. So it makes sense to make your plan for your joint in a spot where you've already got some axes. All right, and the center point is going to be this guy right over here. I'm just going to make a quantity of 1. And I guess this could be a full distribution set to full. Because we're just making something that is going to move and rotate. So it could be set to full. And that could be just fine. But I'm going to set it to 90. And then I'm going to go ahead and say Oakley Dokley. I pushed record, right? I sure did. All right.
Why do I not see my angle?
I don't know. Did you pick a sample?
I did.
Oh, yeah. So it's over here.
Okay.
So if you change from distribution of full to partial,
Okay.
and now you can set it to, I set mine to 90, but you can set it to whatever you want. What we're doing, yeah, so instead of that distribution of full, I set a distribution of partial, so you can kind of make a pattern on part of a circle. Cool.
Yeah, I was still playing catch up.
No, you're good, you're good. Should I move my numbers around so they're easier to see for you?
Oh no, I got that part up to right before you made the pattern.
Ah, cool.
So let's see if unless I missed something.
Yeah, and then you just need a line on the top of your circle too, right?
Like how everybody's mind was wondering at the exact
There.
same instant.
There we go. And then I made mine tangent, so you can usually that's why you use that. Either one.
Glad we're both on the same page with
Yeah, cool.
using those.
So now you can say create, and then you'll make a circular pattern. And the pattern that you'll make is that line and that line. And then those two circles. And then your center point is going to be the circle over here. Cool. And then instead of the distribution of full, I said the distribution of partial. And then set it to 90 degrees. And then I just did, instead of 3, what am I doing? 2. Cool. All right. So now we are done making that sketch. We can go ahead and say finish sketch. All right, so let's go ahead and extrude out some shapes here. So I'm going to go ahead and click on create and then come down to extrude. We've got 2 arms that we're extruding out here. We're going to extrude them out separately, and we're going to extrude them out in kind of opposite directions of each other. So I'm going to start by extruding out my first arm negative 1/4 of an inch. And that is so if I turn this sideways, I mean negative 1/4 of an inch comes towards me for some reason. But I just want to make sure that I extrude out each one of these arms in opposite directions so they don't exist on top of each other. So I'm extruding out one negative 1/4 of an inch, And then I'm going to spin around so I can see all my parts of my sketch. If I was to try to extrude the other section from this side, it won't actually let me click on those sketch elements. Those sketch elements exist on the other side of this body. So I have to use my navigation cube in the top right hand corner to rotate around to the back of my object. And now I can extrude out that second shape, 0.25 inches. Very important. We don't want to join these things together because we're extruding out shapes that physically touch each other. The default here is set to join, and we do indeed want to make a new body.
You had 3D sketches on, then you could click from either side. You could extrude from either
You
side.
can extrude from either side if you have 3 sketches on.
I can extrude from both sides.
When there's a body in the way.
Yeah.
All right. All right, and then I'm going to click OK. I'm going to do a little housekeeping. I'm going to name my sketches. Oh boy, I clicked too many times. So I got a sketch that I'm going to name arms, and I've got 2 bodies, arm 1 and arm 2. I'm going to hide my sketch there. And I'm going to come take a walk and see if you guys got some more. Very nice arms. Yeah, so then when you're making your second arm there, just go the opposite direction and make sure it's a new body. There we go. Cool.
Oops.
A good kind of oops?
No, I didn't.
Okay, good. That is the good kind of oops then.
Oh,
It's not like the kind of oops where what the surgeon says to you while you're on the table in front of him.
No, I can't do what you said. I didn't understand what you were talking about. I just tried to do what I think you were talking about. I can't do it.
Oh, okay, cool. Yeah. All right. So now we've got 2 bodies, and we want to take these 2 bodies and we want to make them move with this as our pivot point here. You cannot do that. End of class. Let's all go home. You cannot make a joint with bodies. You can only make a joint with components. And right now, we only have one component in our document. So we've got one component, it's called the unsaved component, which we have not saved yet. If you want to make a body into a component, you can totally do that. And for instances like this, where I want to draw a bunch of things on one sketch and then turn a whole bunch of bodies into components all at the same time, this is kind of my preferred method. So I'll come up and say, hey, create a new component. Alternatively to this method, the way we would have had to do this is we would have had to say, hey, create a new component. And then inside of that new component, we would make a sketch. And that sketch would look just like one of these things. And then we would say, hey, create another new component. And then inside of the component, we make another sketch. And that sketch would look just like this right here. With this method, we can just make one sketch. And now instead of making a brand new component, I want to make a component from bodies. So I want to convert my existing bodies into components. And now I can click on a whole bunch of bodies all at once. So I could, so I'm saying, hey, new component, the bodies that I'm making my new component from are all my bodies in my bodies folder. I'm just going to click on them individually, or I can click on the one at the top and then hold the shift key down if I've got like 100 of them. And I can click on the last one and it'll select everything in between. It'd be handy to have your bodies named beforehand because your components will be named whatever your bodies are named. So if you've already named your bodies, you won't have to name your components because they will already be named ARM1-1 and ARM2-1 for reasons I'm going to go with. I don't know why it does that, but it does, yeah.
So that's about the same as right-clicking on the bodies and saying create component from body.
Yes, except I can make multiple bodies into components all at the same time.
Multiple components at the same time.
Yes. Mm-hmm.
That's useful.
Yeah. All right, cool. We've got 2 components. One thumb up for each component. Hey. All right, cool. No? Pause? Pausing.
Yes, I was.
Yeah, you're all good. No worries.
I was fixing my one of my first 2 bodies. So
No worries.
I
Yeah, yeah.
basically did not make any components. Do we?
Oh, yeah,
there's
so-
just one component.
So, in order to make a new component, or to turn our bodies into components, we'll come up to create.
Okay.
And then here, I'm just gonna undo, delete. Oh, I don't want to do that. Cancel. Apparently, I can't undo that. So we'll come up to create, and then you'll choose new component, and then you'll choose the from bodies checkbox here. So you're making a new component from your bodies, and the bodies you're gonna make into components are gonna be the ones in your bodies folder. So you'll just click on the 2 bodies in your bodies folder, and then you'll say okay.
And then do that twice, once for each body.
Well, you can do it to both bodies at the same time.
Oh, okay.
Yeah.
Oh, okay.
Yeah, or you could do it to 100 bodies all at the same time. If you had 100 bodies that you wanted to all turn into individual components, you could do that all at the same time, right in that one dialog box. Cool. All right, so now that we've got components, now we can make a joint out of those components. So there are 2 fundamental kinds of joints that you can make here. 2 starting points here. So there is a joint, and there is an as-built joint. At the end of class, we'll talk about this duplicate with joints option. This is new as of July or August. This just got added, duplicate with joints. And this is really exciting. We'll talk about that later. Sorry. And then the second type of joint is an as-built joint. So the fundamental difference between those 2 ways to make joints are an as-built joint are for joints where your components are already in the position that they need to be for the joint to make the joint work. So our things already exist on Revolute point that they're going to rotate across versus part of the process of making just a regular joint is to take your 2 individual components and align them. They live spatially in other places, and now you're going to take them and align them in their joint configuration before you make the joint. So there's an extra step in the joint option. So I always go with this as-built joint option, and then I just draw my joints in the configuration that they're going to be in here. So we're going to choose as-built joint. I am going to change my joint type right away. So a rigid joint is, let's talk about Revolute joints first. So a Revolute joint is between two components. So the two components that are going to be part of our revolute joint are each one of our arms. I can choose the arms here in the drawing view, or I can choose the components in my browser on the left-hand side there. So instead of picking them in my drawing view, I can pick them in my browser on the left-hand side. The snapping point is the point at which they're going to rotate around or do whatever motion they're going to do around. So if I choose that option there, it gives you a little animation. I can play that animation again. There's this preview motion option there. I got a fancy laser. Look, Mike. Sometimes I use the thing that you gave me. So the preview motion button there, we'll preview that motion. It matters at which the operation, the order that you click on the components helps to determine which thing is a moving joint. So if I click on arm 2 and then arm 1 and then set my snapping point. So the first thing that you click on typically does the moving. So there we go. That's the first thing I click on. Typically does our moving here. I'll show you a way around that later. We can set right off the bat. This is new as of this summer as well. So you can set right off the bat a minimum and a maximum travel for your joint. So let's say your joint only can travel from negative 90 degrees to 0. You can set that minimum and maximum, and now my joint will physically not be able to rotate other than those 2 points there.
So, can you explain origin mode a little bit? It seems to talk about placement of joints.
Origin mode?
Yeah, in the dialog box, in the as-built joint, there's an origin mode, 2-edge intersection, and it defaults to simple, but between 2 faces.
I don't see where you're seeing that. Where do you see it here?
Origin mode under components that you selected.
It's the second item.
Oh.
It's kind of talking about the
Between
theory,
2 faces.
but that doesn't quite make sense because
2-edge intersect.
I don't see why it matters where you put the revolute joint in that.
I
space
think
between those.
this is just a. I don't know. Are these like different types of? So if it's between 2 faces, and I choose this face and this face, it's just kind of different ways of locating that that little widget.
Yeah,
So
that's all it does.
Yeah, it does the same thing as that first method.
Cool.
It's just that second method would say, hey, I want my joint to be immediately between
Yeah.
the face that makes up this side of this arm and the face that makes up the opposite side of that arm there. Yeah. You can choose the axis in which you rotate around here. So right now it's choosing to rotate around my z-axis. If that was not the case for some reason, you can make physics breaking kind of things and you can make it rotate like that, which is kind of trippy. That would not function very well in the real world. You'd have a hard time making your joint move like that in the real world unless you were just trying to break a lot of plastic or steel or whatever you're doing. All right, so let's say the joint that is moving here isn't the way we want it to move. And when I made a joint between these two things, I really wanted the upper arm to move instead of this lower arm.
How did you get that ankle adjuster thing?
Oh,
Click on the flag?
yeah, so you just double click on the flag, and it gives you your little angle adjustment here. And now you can type in an angle, or you can click and drag and rotate an angle. Everybody's got a little rotation action? Sweet. Cool. So if I wanted the top joint, the top of this thing to move instead of the bottom of this, I can do that by adding another joint. So I'm going to come up to my assemble menu. I'm going to choose to make another as-built joint. This is where the rigid joint comes in handy. So you would think, like, rigid, why would I want to make something stationary? So you can make something stationary with another component, which is handy in this case. So if I choose this rigid joint, and I choose the arm that I don't want to be moving around when I move my little flag here as one of my components. And now, remember, we don't have two components in our document. We actually have three components in our document. We've got our main document component, and we've got the components that exist inside of it. So I can make this arm 2 rigid with my main document component. And now if I say OK, now when I click on that flag, now my upper arm moves and my lower arm doesn't, because it's kind of a weird thing to wrap your head around, is making something rigid with something that does not exist really. But our main document component is a component that you can make things a joint with. If that may. Yeah, I see some people turning their heads. How can I? Yeah, but this is. I told you.
Is there a practical reason for that, or is that just to cover up a fuck up?
Well, so just like I said, so we can make something rigid that we don't want to move. So this way, only this arm is allowed to move, and this other arm is rigid to the main component. So it's kind of stuck into place in space within the component, which is the entirety of the world. It's like you've taken this piece. If this room is a component, like we've got an empty space here, this room is an empty space. If I were able to glue this mug right here in three-dimensional space, then I wouldn't be able to move it left or right or twist it around, but other things could move based on this mug. Yeah.
Okay, now, let's say that you made your upper arm the rigid one, okay? Between arm, whichever is the upper arm, and your main component, okay? That'll make that top arm rigid, correct?
Correct. Yeah.
Okay, now you go in and you make a second joint and you try to make the upper arm the movable one. Does it still work, or does it break your computer?
So that's a fine question, and I don't think it will work. Here,
The FBI will show up.
let's test this. There are ways that you can make joints with things that Fusion just is like nope, that doesn't move in that way. So if I duplicate that over and I make another Revolute joint here is what you're saying, right? Revolute, that guy. So now my upper arm is the one that's moving here. If I move this joint it moves this lower arm here, right? But you're saying if I make this rigid,
Yeah. When
um,
you spin that joint.
I think that nothing will happen when I spin that joint. So if I make this
No.
one rigid,
The top arm spins. And that was the upper arm was the one I made rigid with the main document component.
oh. So if I make that rigid with that, see mine won't rotate because I've got two components that are locked to being rigid. This is locked to being rigid and this is locked to being rigid. So when I try to move them, it doesn't, and I don't think it will move here either. Oh, well, this one moves because this is not a rigid one.
Do you ever use Motion Link?
I do, and we can get to that next. So, I've got more components than you, haha. So let's go ahead and let's make an adjustment to our sketch here, because I'd like to show off a couple other types of components or types of joints here. So if we come back and edit our sketch, I'm gonna zoom in. You don't really need to do this to show off this type of joint, but it makes more sense visually if we do it. So I'm going to add another couple of lines. So the lines that I'm going to add are going to be lines that are tangent, just like our outer lines here were tangent to our 1-inch circles. We're going to make 2 more sets of lines that are tangent to our 1/4-inch circles. So I'm going to use that same trick that I talked about. I'm going to hold down the Shift key. I'm going to click and place the first point of my line, and that forces that tangency to that 1/4-inch circle. And now I'm going to click and place on my second circle, and you can see I have 2 tangent constraints that are popping up there. They're kind of hiding in with the other options. And I'm going to grab my line tool again, holding the Shift key. So we're making a slot effectively here. We're making a slot in that joint, or in that component, in that part. And now I'm going to say Finish Sketch. So I'm going to go ahead and I'm going to delete all my joints here, because we kind of learned how to make a revolute joint. And now we're going to do a pin slot joint. So I'm going to just right click on all of my joints in my joints folder and say delete. When you do that, you'll also notice all of your joints down in your timeline disappear too. So effectively deleting the joints in your joints folder is the same thing as deleting the joint features in your feature timeline. Yeah, I'm deleting the whole joints tree because I'm going to make all new joints. Well, you probably can't delete the whole folder all at once, but you can select all the items in that folder. Gotcha. And delete them.
Yes, you can.
And then the last modification that we need to do here before we can go back to making our joints is I'm going to grab my extrude tool, and I'm going to extrude out. I turned back on my sketch so I can select that slot that we just made, and I can extrude it through my body, or through my component, excuse me. Here's an example where you can choose, instead of a distance, instead of setting a specific distance here, you could choose all. And now later, if I change the size or the thickness of this arm, I won't have to re-extrude out my cut through that because it will always be set to all. So whatever thickness this arm is going to be the depth of my cut there. Yeah.
I was playing catch up, and so if you can close that out, I did that.
Sorry. So you want this feature back up here? Is that what you're looking for? Yeah, so we're extruding out that entire slot. And I turned off the visibility on my arm too, and that way I was able to click on all my sketches.
I select all, it doesn't do anything. Because my arrow is backwards.
Oh, interesting.
So, maybe if I change it to cut, then it'll cooperate.
Try moving your arrow into it.
Sure.
And now say, oh. There we go.
Good idea.
Yeah, so you want to turn on some of your bodies. This component. There you go. Yeah, now you can move your navigation cube so you can make sure you're cutting and moving in the right direction. And I think you want to go move your arrow. You want to extrude that arrow towards you. Perfect. There you go. Cool. Nice slot. All right. Cool, good.
Gucci.
All right, I'm going to go ahead and say oakley dokley. I'll turn on the visibility on my component that I turned off, because now we've got a slot that we can move through. So in this as-built joint option again, so we'll go to assemble, and we'll choose as-built joint. The kind of joint that we want to make is a slider joint. So that's kind of what we got right now. We got a slider. There are kind of two different kinds of sliding joints. So this is the first one. The components that we'll pick on, again, I believe in all cases, the first component that you pick is going to be the joint that does the moving. So you pick the moving joint first, and then the static part of the joint second. And now I can choose the slider. Oh, this is kind of a weird. The slider is going to be a straight line that runs. I think any one of these straight lines will work just fine. So I picked that inside line. I could pick the outside line there. That works just fine as well. I don't know what's going on. Oh, see, something. You could pick a face apparently as well too. So when I choose the face, it moves in this way. But I bet I could change my slide direction now. So in the motion section here, instead of Z, if I choose X, then yeah, so that works just fine too. And again, here we can set limits. We can set minimum and maximums to our joint, which really makes sense in the case of a sliding joint, because you can only go so far. So there's our minimum and our maximum. Right now.
Since I put the wrong axis, just tell me how to fix it.
Is that?
Like pressing
Oh, sure, coming back and forth. Yep.
because I actually picked the wrong axis, and now it's
Sure. Yeah, yeah. Yeah, now you're good to go. And you could add in joint minimums and maximums.
Oh, those are in inches, not degrees, okay.
Yeah, those are where we're sliding. Yeah.
Okay, Carl.
Yeah.
How do you, pick your origin on this, or the
So we've done
snap?
our two. So now if you pick any straight line that runs sideways,
Like so?
like that. There we go.
Your joint at rest.
Oh, it should automate there. Uncheck your two components. And click your components.
That's what I did here, front arm, back arm, spider joint. Okay, and it should be a bigger box too, shouldn't it?
Yeah, it should expand out once you choose that
Okay, let's,
snapping point. So if I get rid of my snapping point here, so yeah, your box looks like mine now, right? Where I've got
that's what I'm trying to do, it's not happening.
it won't let you pick your. You can't do it either. You can't pick your snapping point.
Okay, assemble. As built joint. Slider.
Is working good?
It wasn't, but I'm trying again.
So you'll pay. You get your two components, and now you pick one of those straight lines.
Oh,
Oh,
Just like
and
that.
the line.
you're doing fine then.
Yeah, why isn't it moving? Hey, there we go. Maybe try clicking. Yeah, there you go. So that's close. But now you can just change your axis. So instead of z-axis there, you can say x. There we go.
Okay,
There it's moving. Did you get your part too? You can double click on that little widget there, and now you can push and pull that arrow around.
So you want to play the animation?
Well, you can go back to edit the joint. And then there's like a scroll down, and then you can hit the play button.
Is there any other way to view the action
Not,
besides that?
not that I'm aware of. Not that I'm aware of. You can motion link some things.
Animation, there's nothing in that.
Yeah,
As I thought it was.
yeah, not that I'm aware of. So the last type of joint here that I want to talk about is here. If I uncheck my little slider and uncheck my components. So if you go back to here, let me get to where you guys would be at here. So here's the thing is what you really have to do is you have to click on 2 points on a line. So it was working for me because I chose to pick this face, and then I could change my z-axis to say, hey, nope, it's really sliding on the x-axis. But the way that I was explaining to do it is pick a line, and then you actually have to pick a second point on that line. And then it will start moving around. So now it's my z-axis according to the line. Yeah. All right. So I'm going to delete that joint again. Or never made in the first place. And then the last kind of joint here that I'll talk about is the pin slot joint. There's a whole bunch of joints here you can see. So I've never actually used the ball joint before, but that's kind of cool. I didn't know that was a thing. But if we choose the pin slot joint, this is kind of a combination of the two joints that we picked. So if I choose the first joint first, the horizontal arm first and the vertical arm second. And now I can place a snapping point that looks very similar to what I did the first time, except it's got this added component of a slide axis. And I actually am going to reverse the order that I choose my joints. So I'm going to choose the vertical arm first, the horizontal arm second, and then place my joint, because that is the motion that I was expecting to see there. And here I can, so I can set some minimums and maximums. I guess I can only set a minimum and maximum rotation. I can't set a minimum and maximum distance for whatever reason. All limits? Yeah. Yeah, so that is the last type of joint that we'll get to talk about here in this class. And then if I say, okay, now to move these around afterwards, I double click on it. And now this joint has both the arrow and the rotational thing. So I can move this along that slot there, and I can also rotate it to any angle that's within the joint limits that I chose. So theory classes, thumbs up, thumbs down. If you're watching on the YouTube, you can leave a comment below and tell me that you like theory classes or that you hate them and you just want to make projects.
Like, comment, subscribe.
Right, yeah, exactly. Like, comment, and subscribe. If all of you subscribe to my YouTube channel, I would double my subscriber count right now. So no, you don't actually need to do that. I like seeing you all in person. So if you're interested in these kind of like theory-ish classes, we can totally do this. This is a thing that is doable where we can do like more deep dive-ish on a specific targeted area here in Fusion, like we did joints today.
Yes.
Keyboard shortcut idea.
Keyboard shortcuts, all right, cool.
Good.
Yeah.
The existing standards.
Yeah. We could definitely do that.
And possibly a handout for those slower members.
A fun handout. Yeah, I could totally make like a little keyboard shortcut
I'll take a cash.
key. That could be super fun. You
I'm
know,
more interested in like today, just going into a thing I can do. So
yeah.
Since I'm not going to be making a living with this, I don't need the keyboard shortcut.
Not with that attitude, you're not. You know, I will say that the one thing that we didn't get into here that I think is really cool is drive is you can have joints drive other joints.
Yeah.
So
That's what I thought Motion Link was, but it's not.
well, that is what Motion Link is.
Uh-huh.
Yeah. So I use that a lot with gears. So I've been having a lot of fun with making gears. You can make helical gears. We talked about the helical gear component at one point, or the helical gear add-on. And so the helical gear add-on makes individual components.
We
And
never
then-
got through that class.
What's that?
We like started it. I know we never got
Right on. So if I make another joint here, this and we make it a revolute joint. And this guy, and I change my pin slot joint. You guys don't need to follow along here. I just kind of want to illustrate a cool thing. So now these joints move independently of each other, but if I wanted to, I can say, hey, make a motion link. So assemble a motion link, and I want to link this joint and this joint together. So now they move in concert with each other. And importantly, when you're working with gears, there's going to be inevitably some sort of ratio that you're working with. You've got a small gear that's going to move very quickly and a big gear that's going to move very slowly. You can have a, first of all, it would be reverse. When you do a gear, you have that reverse thing picked because they move in opposite directions of each other. And then normally what I do, because I don't like doing math, is instead of an angle, if this was gear and one of my gears has 60 teeth on it and the other gear has 10 teeth on it, I just put those in and that ratio works out just fine and I don't have to do any math. We let Tom do all the math in here. So, but yeah, and that's kind of a tricky thing. You can do weird stuff. That's moving a little fast.
Do 60 to 1.
Yeah. So, drive joints are cool. So now, you know, it's doing that animated, but I can just click on this joint and I can move this one joint and the other joint moves here now too.
What if you wanted more than 2 components to move together?
You would just link up as many
Select
components.
3.
Yeah.
You could select multiple joints.
I don't think you can select more than 2 joints at once
That's why
using
I'm
that.
asking, 'cause when I read about this a few days ago and it said there's a way to hack around it, but it sounded kind of like they only want you to do 2 things at once, but like a clock, you know, has multiple
Yeah,
things working
and
together.
you know, if you're gonna have more than one motion link, a practice that I've been trying to follow is if I'm gonna have a whole bunch of joints that are all linked together and they all need to move together somehow, I link them all back to the same joint. So I got one joint that's my drive joint and everything is linked back to that one drive joint. As opposed to having to try to remember, all right, what is this emotion link between? This is emotion link between this one and this one, and then this one is linked to this one, and then this one is linked to this one. So to figure out a way,
The last one that you linked everything to should animate all the gears.
they would all animate all the gears, no matter which one you move,
Gotcha.
because they're linked to each other.
The moving
They
one
would,
animates everything.
yeah, moving one moves them all. Yeah. So cool. So yeah, motion links are cool. We can do more gear. We can do more gear. We should do a clock project again. Is what we should do.
Yeah.
During the pandemic, we did clock project because everybody was bored in their houses, and they would just listen to me for weeks on end. So we can
Transmission
that's over my head. I
It's
so maybe I'm into it. But all right, cool. Thanks for being here. We will see you next week.